Let's try to run the shell, and let's do, for example, ps. Okay, it's showing me the processes. ls, lss. Okay, cell junior failed, no such file or directory, because we don't have the command. Let's call htop. Okay, it works. ls, la. Okay, as you can see, we have something primitive, of course, but let's try cat. Okay, it works. If I do Control D, it's gonna get out. Control D, okay, gonna get out. All right. Hello, my friend. Today I'm gonna build a super simple shell. This has to be an MVP, namely a minimum viable product. Something that barely works, but can explain the underlying principles of a shell. A shell is basically a computer program that exposes an operating system's services to a human user or other programs. TLDR, it's a program that allows the communication between the machine and an user. I personally use fish shell, but there are many of them. Like, for example, bash, which is probably the most famous shell. Okay, let's start to write some code. I create my directory, my cell, and I cd into it. All right, let's create a cell.c, which is the main file, and we start with the main function as always, right? We don't need command line arguments. We return exit success. Let's create another file called cell.h, the usual guards, cell_h, like that. And here we put the actual libraries that we need. We're gonna include the standard input-output library, and we're gonna include the standard library. So we can use the exit success macro. So at the very top, I'm gonna include cell.h, like that. Perfect. Okay, let's do a simple test. Hello, let's run this, and it works. Now, I will write a super simple piece of code to show you what I would like to do with this super simple shell. Let's use argument counter, char star argument vector. And here I will create a super simple implementation of a single use shell if you want. I don't need the argument counter. And what do I need? I need the fork system call. So I will include this here, include Unix standard if fork equals 0. Namely, this is a child process. What do? You exec vector p, and it passes an input argument vector in position 1 and argument vector +1. Later I will explain exactly what that's happening here. After that, I just call wait. Wait requires a pointer to an integer, which is the status. So I will declare that, and here I pass at status. All right, we are done, essentially. This is a one-use shell. Let me explain to you. Here I compile my one-use shell, and then I launch with the command that I want to use, for example, ls-l, enter. And as you can see, I have the ls command that has been run, right? If I do only ls, enter, and I get ls. As simple as that. So essentially, what do I have? I have my main process that is creating a child with the fork system call. The fork is returning 0 for the child, so this is the child block. The child is executing this exec function. Now, what is this execvp doing? It is basically replacing the current process image with the new process image. Which process? Well, this ls, right? V stands for vector, which is this command line argument, and P stands for path. Path is our environment variable in which we have all the paths to executables. So it's going to search for this ls in all the places indicated by this environment variable. So when we call exec vector path, we are passing ls, which is the actual executable that I want to launch, and av, which contains these elements in our specific case. So TLDR, duplicate yourself, change yourself with the ls command with these specific inputs. The father is gonna simply wait for the child and is gonna stock inside status the return value of the child. So in my shell, I want to implement this logic in a loop. So I need to prompt the user to please enter a line. I will parse that. I will divide into tokens. I will create an argument vector of tokens given the input, and then I'm gonna execute that specific line. That's the basic idea of a shell. So basically do this in a loop, not in only one shot, right? We have all the times to read the line, understand the line, divide into tokens, create an argument vector, and then execute, and so on, until the user wants. All right, so we have to implement the so-called REPL. That stands for read, evaluate, print, and loop. This can also be called execute. But if you search online for REPL, you will find what I'm talking about. Basically, a read, eval, print loop, namely an interactive top-level shell. So for sure, I need a loop, an endless loop. Let's start with that. So let's do that with the magic number cell, and then we need step 1, get the line, right? Step 2, evaluate, namely get tokens. In this imperfect cell, this is gonna be performed with the get token function. In future videos, I will do lexing parsing, which is the correct way of evaluating stuff, which simply means allow the machine to understand what is going on. Third step, well, exec. So let's start from getLine. For this task, I will use the function getLine coming from the standard input-output library, which is basically a function that reads a line from a stream, exactly what I need. Now, the cool thing is that if line P points to a null pointer, so our buffer, a new buffer will be allocated. So we don't have to worry about the size of the actual input, because we don't know beforehand how big the input is going to be. So it's pretty handy for that. Now, there is a better function that suits the need for a shell, which is readLine, that comes from this library. A readLine indeed provides line editing and history capabilities for interactive programs, so with a command line interface such as bash. So this is a perfect fit for a shell. As you can see here, you have all the things you can implement, and this is a little TLDR on how you can use this function, like that. So you can see you have an endless loop, you're prompting the user for an input, you head into history, and so forth. You do stuff. I will use this function when cell is going to absorb in the future C17 and C18. So let's declare in my main char star, which is going to be the line. And here inside the loop, I can do line is equal to cell read line. This function that we have to implement, like that. So let's implement the function. It's going to return me back a string, cell read line, no inputs, and let's move on. So as we previously saw, we require a buffer and a size t value, which is the size of the buffer. So let's do char style line or buffer, and the size t buffer size. I will say that buffer is equal to null, so getLine will take care of it. Okay, now we're ready to call getLine. So getLine returns me the number of chars written, otherwise the value -1. So let's do if getLine, we pass the address of the buffer, the address of buffer size, and the stream, which is standard input. Okay, if this is equal to -1, we have a mistake, which is basically if an error occurs or if end of file is reached. So here I can say if f end of file stdin. Basically this function tests the end of file indicator for the stream pointed by the stream, returning non-zero if it is set. What do? You just printf end of file, else you just printf get line failed, like that. Now we can add some colors here so we can see better the mistakes. So we go back in our file.h and we include NC colors. I made this with ChatGPT in just 1 second, so it's pretty straightforward. Also, one thing I like to do is to redefine the printf. I don't want to write all the times printf. You can do very simply in this fashion. You just put a p, an ellipsis, and then you print the printf like that with variable arguments as an input. Perfect. This is just a simple shortcut. Okay, let's go back and let's do here p and p, and here let's put red and reset. Here maybe you can also do a macro like print error or whatever, but I don't care now. Okay, so at this point we need to simply return the buffer. Now in the case of mistake, let's put a null inside the buffer like that. Buffer null. Now here I'm not sure if getLine is changing the actual buffer in case of fail, so I can just simply do a test. Here I'm just gonna print %s my buffer like that. So this is just a test. Okay, because I think something happens with the buffer. Okay, let's test the code. I will do that also here. I will call pause like that. Here I just put line and I do Control D and I get, of course, this and the file. But when I print the string, I don't get the null. Here I should write something like this. Should be the case. Null in parentheses. So let me change this. In case of end of file, you just refresh the buffer to null. Okay, let's recompile. Let's launch. Okay, Control D. And this time I have my null. Okay, Control D. Perfect. All right, seems that I need to refresh to null, because even though getLine fails, the string changes. Probably it's a pointer to an empty string. Okay, like that. So it's going to return me the buffer. Now, one very important thing that I have to do before the getLine is to write a prompt, right? I need to tell the user, please enter something. A very simplistic approach would be something like this, right? You just put $1 and a arrow like that, and you get this, right? You write your string, enter, and then of course we get impose here. Let's remove this. You write a string like that, and this is how it works, right? We can do much better. I want to emulate my fish that is giving me back the path, the print working directory, right? Here you can see that here. I want to do something similar with my prompt. So there is this get current working directory function that is doing exactly that, which is copies the absolute path name of the current working directory into the memory reference by buffer and returns a pointer to buffer. So let's create my buffer. So char, I call this current working directory, and the size is going to be, I don't know, buffer size. This is a macro that you can find inside the standard input output header, and which is 1 kilobyte. Totally enough, right? Allegedly. Totally enough, allegedly. Now, I can do something like this. Get current working directory, I pass everything, but I want to create wrappers. I want to make a file in which I have all the wrappers. Let me show you. I do edit utils.c. I want to include cell.h, and I will have all the wrappers. Basically, they are functions with controls embedded. So my main code, quote unquote main code, is more clean. So what do I mean? Basically, I'm gonna do a char star get current working directory, this time with the uppercase. The input is going to be the actual buffer, right? Char star buffer and the size. So size t, size. So here I simply check return value. Upon successful completion, a pointer is returned. Otherwise, a null pointer is returned and the global variable I don't know is set to indicate the error. So you do if not or null is equal to get current working directory, buffer and size. You call p error, get current working directory failed. I can do this in red, okay. And then, I don't know, you can exit or you do whatever you want, you handle the way you want. I just do return buffer, which is kind of redundant, right, in this case. So I can do it better. I can do get working directory, that is returning void, and that's it. So you just do like that. So I have the control embedded in my get current working directory. The thing is that a pointer to the path name is returned, but the thing is that this is already copied inside the buff thing, so it's kind of redundant, I guess. Anyway, you got the gist of it, right? I just want these wrappers, so I don't have to worry every time about the returns in the main code. Okay, so I put the prototype and we're ready to rumble. So in my cell.c, I just call get current working directory, and here the buffer size is going to be size of current working directory. And now I simply have to print the prompt for the user. I have to check if there is a function which is isa_tty file number stdin. Basically here I'm saying, hey, are we in interactive mode or this is a script? Oh, anyway, given that this is a dump shell, let's just forget about this for the moment. We're gonna do with perfect cell. So here I simply print the prompt. I can do print. Let's use some emojis, like 2 cells, and we put %s, which is the actual path, which is buffer. Okay, and at the very end, let's do $1, the classic thing for shells in this fashion. All right, here we put some colors. I can do in cyan, like that. All right, so that's it for my read line. Let's try to run this code. So cell.c, unused parameters. Here I have the flags, so I can do void argument counter. Let's do again. Also argument vector. Well, basically I can simply delete this. Okay. I have null. Now, of course, what an idiot. Here I just put buffer, but not current working directory. These should be split into functions. You see, I got confused about the printing the prompt to the user and getting the actual line. Anyway, let's do this again. Okay, let's run. All right, here it comes. You see, you get your prompt with the current working directory every time. As you can see, receiving my thing, Control D, is gonna get an infinite loop to end of file. So we can move on. I can put this inside. I can put the read line as a condition of my loop. So I can do this. Let me show you. Exactly like that. So I'm telling it, hey, until I have one line, keep reading. So let's try again. So let's see, utils.c. All right, if I do Control D, all right, end of file, and the loop is gonna end because here I'm gonna receive this null. All right. Now we want to do something cooler than this simple thing. I want a big banner like writing cell version 1 or something like that. How do we do that? Well, you go on a website like that, text to art generator. One that I like is ANSI shadow, like that. I can do cell version 1, something like that. Then you simply copy this and you create an ad hoc function like that, right? With a simple printf. Okay, just add this print banner. All right, here just before I just do print banner like that. Okay, let's try again. And this time you get this output, which is nice, right? Now the problem is that every time it gets called. I don't want that. I just want this at the very beginning. So of course I have to move this print banner in the main, just here at the top, like that. Let's run again. Here it comes. So now we have something nicer, right? This is the layout. Control D and I go out. Control D, end of file. So that's what happens. Okay, now we need to add some functionality. We have made the get line. So this is actually done. Get the line and namely prompt plus get line. All right, now it's time to actually use the get token function. If you recall at the beginning, I showed you like we used the argument vector, right? Which is just a pointer to various strings, right? It's just the structure or something like that. We have we have different strings. We can have like ls, all, file, something like that. So I want to recreate this. I'm not gonna do lexing and parsing, which is way too complicated for a beginner video. If you're interested about these things, I cannot suggest more this book, which is Crafting Interpreters. There is a free version, so that you can read online. And you go here, a 3-walk interpreter scanning. And this is explaining extremely well what a token is, how it works, what is the meaning of a token in a very funny way. I really cannot suggest this more. The problem is that this is written in Java, but you can extrapolate meaning very simply. Now, with this little program, I want to show you the string token function, what is going on. As you can see here, I have one string, which is mimicking a shell command. And then I call the function cell split lines. So in my shell, I will use this function, cell split line. So here, as you can see, we have an array of pointers, essentially like the argument vector in the main. And then what do? I have a for loop in which I have char star token, calling string token, line, and a specific delimiter. Delimiter in this case is just a space, okay? So the string token function is returning me back a token, delimiting with a specific char, which is the space. As you can see, the string token function is used to isolate sequential tokens in a null terminated string. So this is a primitive way of determining tokens. Token means something that has meaning in a specific context, in a specific language. So I will keep fetching tokens from the specific string, which is line, this one, until I have a token. Every time I will upgrade the token variable with a new token, calling again string token, but as a first argument is going to be null. Here, just reading from the manual, you have that the first time that string token is called, string should be specified. Subsequent calls wishing to obtain further tokens from the string should pass an null pointer instead. So that's exactly what I'm doing here. So the first time I call string token with the specific line, and then I'm calling again string token, but this time with null. So until I have a token, keep going on and put inside my tokens, which is my argument vector, like data structure, in position plus, we start of course from 0, the specific token. After that, I'm just gonna print all the tokens. Let's try to run this program, and as you can see, I have all the tokens, ls, la, file.txt, pipe, and cut, thanks to this delimiter, which is the space. Now, if I change the delimiter to be a $sign, what do we get? Well, something different. This is considered one token, one entire token. So as you can see, the tokenization is pretty primitive, but it's fine for this specific cell. So a token is a space-separated thing for this shell. This is what is going on. A space, everything that is space, right? With that, I mean everything that's all these charts, the tab, new line, vertical tab, and so on, everything that is used by the isSpace function. So let's rewrite this together. Let's accustom to my goals. I'm going to return an array of strings, exactly like argument vector. Function is called cell split line. And as an input, we have a char star line. So the goal is to go from ls, la, file to something like tokens, ls, la, and file. This is the goal. I want this data structure to be returned to the caller. All right, so get the tokens is going to be done here. Cell split line, the line is going to be a line, and we have to declare a char star tokens, or we can call it arguments, args, like that. Yeah, I will use arguments. All right, let's implement the cell split line. So we have our char star tokens, and we have two tokens. We have to malloc. Again, I will create a wrapper, so I don't have to check for errors of the malloc. It's gonna be malloc of what? Let's do again buffer size per size of at tokens, like that. Now, of course, we have to implement the malloc wrapper. So here we have buffer size that we previously saw. It's 1K. totally enough, hopefully. Per size of at tokens. At tokens we have a pointer. So we have 1k pointers. So let's go to utils. Okay, here pretty fast. I implemented the malloc wrapper. It's super easy. I don't want to make the video too boring. It's very simple. You call the real malloc inside, you check for null, and here I just call exit failure in case we don't have a pointer. Cool. All right, now we have to populate these tokens, and we do exactly like I showed you before with a for loop, in which we are gonna declare a char star token, which is equal to string token. We have to include string.h in cell.h. Let's do that. String.h. There you go. So we pass as the first input line. And here we need a delimiter. So I'm gonna do a macro that I call del in my cell.h. Let's define del delimiter with all these chars, which are new line, tab, space, and all the ones declared in the espace function. So there you go. So these are gonna be the delimiters of our tokens. Now let's go back to cell.c, and we keep fetching new tokens until token is not null. So token, and again token equal string token. This time we have to pass null to fetch the new one, and again separator is the same, delimiter separator as you want. All right, so in my tokens, in a specific position, so I do a variable, let's say unsigned int position. Let's say position is equal to 0. So tokens in position plus plus is equal to the current token. At the very end, you put a tokens position is equal to null. Namely, I assign null, not is equal, like that. So this is a sentinel value. And then at the very end, you return tokens. All right. Now here we have to check also if there are more tokens that are in buff size, which arguably not, but you never know. So you do if the actual position is major equal, then buff size. Now this is not a good pattern, because if I change this later, I will need also to change the code. It's harder to refactor. So maybe here we can do a variable. We do a size t buff size, and we do buff size. Buff size is equal to buff size, like that. And here we put the variable. Now the code is easier to refactor, right? And what do you do in this case? Well, you can do, so buff size, you multiply per 2. We go to 2k, right, in this case. And you need to realloc, essentially. So you do tokens is equal to realloc. So I'm gonna create another wrapper. So I do realloc of what? Of tokens. And the other input is gonna be buffer size per size of at tokens, like that. So same pattern as before. This is the wrapper for the realloc function, in which we have the embedded control. And there you go. So we are basically done with our split function. So this is gonna return me all these tokens, space separated strings. Okay, so back in the main, we stock inside our arguments the cell split line. So get the token. This is again done. Let's make a simple test now. Basically here I'm writing a loop to see all the actual tokens. Okay, let's run this. Just write ls, la, and here you can see the actual tokens, right? So space separated things, whatever it is, that's what happens. Essentially, if you do a command file, then I don't know, you do pipe cats, so you do something like that in your shell, you see, you get all the actual tokens in this fashion. Okay, I think you got the gist of it. Now, one important thing that I was almost forgetting is that we have to free stuff, right? I don't want to have memory leaks, especially in programs which are interactive, continuously mallocing memory. So we have to free the line, and we have also to free the arguments, like that, at the very end of every loop. Perfect. And also here, essentially, I need to do a free right, of buffer, as I understand. Okay, so seems everything is fine because I have an empty strings if getLine failed. Nonetheless, it's malloced. All right, let's go to exec. To do that, we are going to create a function that I call cell exec that is going to take as an input the various arguments at this point. So we have our list of tokens. We just need to do the thing. Okay, so to do. Okay, let's do the function. So it's going to be void cell exec. Input is going to be my argument vector, kinda. I do char star star arguments like that. Now at this point, we have to check first of all, is a built-in the thing that I want to launch? Because if it is, I just call it directly. Is code which is found inside the shell. On the contrary, you have to call exec, right? Execvp, as you saw initially in the video. So the flowchart is essentially like that. We do else fork plus execvp plus wait. So built-ins are functions which are found directly inside the shell code. Let's say that I want to implement 3 of them. Let's do echo, env, and exit. I do them because are very simple to implement, like the basic implementation, of course. Now, what can I do? The idea is to have a list of them and you loop. Is echo the thing you're looking for? Is env the thing you're looking for? Or is exit? Because these are built-ins. So in that case, you don't have to do this fork exec and wait. So what can I do? I can create a struct containing all these built-ins. It's primitive, but gets the work done. So let's go in my header and let's do a struct that I call built-in. And inside we have a name. So const char built-in name. And then we have a pointer to the actual function, which has this prototype. Let's say is returning me back an integer, and I have the name, and then I have the input, which is the argument vector thing, right? Like that. So this is the prototype of every built-in. Of course, we can become fancier and have different built-ins. We can, for example, create an union here, right? In which we have different function prototypes here. Anyway, given that this is imperfect cell, we're gonna have only this prototype. All the trim functions are gonna have this prototype, echo, exit, or whatever. Okay, let's just typedef this. I do typedef struct type built-in. Here we are. Now, in my cell.c, I just declare a global type built-in. I call this global built-in, which is an array. Okay. Then now I'm gonna populate. I'm gonna populate with all the built-ins that I have. So let's initialize everything. I'm gonna have built-in name equal to echo, and the function is going to be cell echo. Of course, I have to implement this. Okay. I'm gonna do also this for the environment. Function is cell m, and exit, doing the same thing, cell exit. All right, at the very end, I just put a sentinel so I can loop easily. I do built-in name is equal to null. Okay, so I have this global built-in with all the built-in functions that I am gonna implement. Of course, this is not scalable, but for the sake of argument, this is gonna work. And given that we only need a minimum viable product, it's fine. So what is the idea that I have? Basically, in my cell exec, first of all, I want to check while in the global built-in at position I, I'm gonna declare this int I equals 0. Of course, here I have to put at, so global built-in dot built-in name. So let me save this in a variable constant char current, like that. So your current like this. So basically I'm looping all of this, right? Until I have a built-in echo and exit, until it's not null. You do a string compare, right? You do if string compare current and arguments in position 0, right? So args 0. It supposedly has to contain the actual command. We assume that there are no mistakes. Of course, attention here, because string compare is going to be returned 0 if the strings are equal. Well, in this case, if it is one built-in, you call it. So you do global built-in at position I dot foo parentheses args. This is the weird syntax to access the actual function and call it. All right, by now let's leave it to do. After you call it, you return like that. All right, and at the end, if it is not a built-in, here we simply increase I. And at the end, if it is not a built-in, you call a function, I don't know, you call it cell launch. This is gonna be the fork exec thing, like that. All right, that's the basic idea I have in my mind. Now let's implement these built-ins. So I create a file, I call built-in, include cell.h, and let's implement, for example, int cell exit. Okay, so I want this function just to exit, so I don't need the arguments. So I call the system call exit success. I just want to make this super simple just to show you the overall principle of a built-in. And here we can do something fancy. So here I create a super simple function that is gonna show you an animation, like sending a Kamehameha or something, just for fun. No utility at all, but coding is fun. Don't forget about that. And here in built-in, okay, I add this to the prototypes. And here in built-in, I just use it. So Dragon Ball spinner loading. All right, I just want to test the code. So let's see, let's go back. Just by now, I'm gonna comment out all of this. I just need to put the prototype cell exit here, like that. And I just made a mistake, like cell.h, cell exit takes arguments, so it's char star star, like that. Even though it's not using, takes this as an input. Okay, we go back to cell.c. Okay, here I just need a comma. Is this the problem? Place comma, and here at the very end, like that. Okay, silly mistake. And here in built-in, okay, I did it wrong again. Int. Okay, the prototype has to be exactly the same. Now, this is the problem on coding live. You do these silly mistakes. All right, cell.c. Now we rumble. All right, so let me comment this. I just want to test if this works. Cell.c, utils, and built-ins. I run, everything works. If I type exit, you can see that we have my animation. And the program should exit correct. Okay, there we go. So basically, this is a built-in, my built-in exit. Of course, I should write a manual telling, hey, this shell is providing you these built-ins. For example, in Fish, you can write built-in names, and it's showing you all the built-ins of the shell. So these are inside the shell itself. They are not programs outside. That's basically the idea here. So you can have all your built-ins like echo or environment. You just have something like that. Now I'm not gonna implement these built-ins. You just have the idea, the overall principle on how to do that, just using pointer to functions and whatever. Okay, so now we launch the function and we want to have a variable status or something of the last thing. We can do here a global variable I call status. Initialize to 0, and every time we stock the return of the function. So built-in. Now my specific built-in is gonna exit, but other function can have a status like, hey, everything is fine, and this is gonna be stocked inside this global variable. Like when I do ls with my shell, everything is fine. If I do lss, I get this return status exit. To make this point clear, let's implement also environment very fast. So I will just write very fast the function. As you can see, the prototype is still the same. Of course, all my built-ins have the same prototype. This is primitive, but just to show the point, I use the environment variable with the keyword extern. Extern simply means this variable exists, but it's defined somewhere else. basically is defined in the C runtime and not directly in your program. So we need to tell the compiler this variable exists somewhere else, not defined here, but I want to use it. So we use extern, as simple as that. The environment is like argv of the environment variable. If you do env, you will see all of them in my fish shell. So as you can see here, I say if not environment. If I don't have this variable, I'm going to return 1. Mistake. If everything is fine, I return 0. Here's just a simple for loop printing all the environment variables. So I hope you understand the point of this global status now. That is going to be showed you. Now let's go to cell launch very fast. The function has void cell launch char star argument args. And we have to do basically forking. When we fork, we are creating a clone of the current program. Fork is going to return 0 if we are child. So we can do that. In cell.h, we define cell junior equal to 0. Of course, I want to do my usual wrappers, so later I will implement. Fork is equal to cell junior. So if we are the little clone, what do? Well, you call exec, again, another wrapper here, exec vector path. And as an input, we get args in position 0 and args. This is the way exec works. Basically, this is the command of replace the current process image with a new process image. As we saw previously, right? Takes an array of arguments and uses path to find the executable. If we have these tokens, these arguments, we have to pass ls, which is arguments in position 0, right? This here, and all the actual arguments, which is this variable. That's what happens here. Okay, so very fast, let's implement fork and execvp. So fork is pretty straightforward. We call the fork function. If p is minor than 0, p error, and you call exit with this symbolic constant that comes from here, from 6exits.h, basically system error, something x, for example, can't fork. So you just exit. On the contrary, you simply return the PID. Simple wrapper for the fork. Same simple wrapper for execvp. You check if you have null pointers. If everything is fine, you call execvp. If you have -1 as a return, p error, cell junior failed, and you exit with exit unavailable, which is basically another symbolic representation of 69 service unavailable. We do that. Okay, execvp should never return. If it returns, we're failed indeed. Okay, so if we are the father, what do? Well, we are gonna call the function again, wrapper wait bit, or better, given that we want super simple, I'm gonna just call wait. Wait only requires a pointer to status. Basically, as you can see, it's a family of functions. So given that this is super simple, I'm gonna only use wait. Now, as you can see, we have macros here to filter properly the exit status. And this is the wrapper for the wait function. I check if the status pointer is null, and very simply I control the return of the wait goal. Now, one thing, as I was telling you, we have to filter properly the status. So I'm just gonna do that. So just before returning, I do if exited at status, you put at status the actual exit status. Now, this may seem weird, but essentially what happens here is that we have some shift operations. Basically, the real exit status is encoded in a specific way, so we have to use these macros to really fetch the real exit status. Anyway, as I understand, right? I don't know if I'm totally accurate here. Okay, I guess we're basically done. Let's try to run the shell, and let's do, for example, ps. Okay, it's showing me the processes. ls, lss. Okay, cell junior failed, no such file or directory, because we don't have the command. Let's call htop. Okay, it works. ls, la. Okay, as you can see, we have something primitive, of course, but let's try cat. Okay, it works. If I do control D, it's gonna get out. Control D, okay, gonna get out. All right, something really primitive, but that is doing already something. That's essentially a blueprint of a shell. All right. You have the basic idea on how to do a super simple imperfect cell. All right, I will refine the code, but you got the basic idea if you saw the video till here. I will put it in the description if you want to play around. And I plan to do more advanced shells in the future, so we'll start with imperfect cell and we move on later until perfect cell.